analytics, integration, acquisition, and infrastructure. So in between the all the ICT and the services. So we have different types of things in the analytics where machine learning, predictive analytics, data mining, integration of sensor data, economic population, GIS, and then interconnectivity from the Bluetooth, Zigbee, and the Wi-Fi, acquisition, sensor, and the cameras, and infrastructure of sensor data, economic and population. So this is the main problem what we have discussed, that over 50% of world population lives in the city and growing, what we have discussed, that over 50% of world population lives in the city and growing, and by urban areas. And there will be a need of live in the urban areas, and there will be a need of my water, electricity, housing for city living, that transform into the quality of life, and whatever quality of life is a smart city. Whatever quality of life is a smart city. When we are talking about the problem, that how we are solving the problem. So there are so many companies giving the solutions for the sustainable smart cities, and Cisco, Intel, Huawei, IBM, Fujitsu, Siemens. They are selling the ICT solutions for the smart cities. So there are some high cycles for the smart cities. What are the expectations for the framework, IoT governance, and the energy harvesting? So here we can see there are so many ISO trademark of areas which are measured in the 2014 for deriving the smart cities, for the solid waste, smart shelters, safety, like what we are living in the metro cities in the of the India, and there are so many challenges, like what there are challenges, like what there are like given by the smart like given by the smart strategy in India, and first challenge is the e-governance and the citizen services, what we are just looking after the Mahakumbh, okay, and they have invented the ICT solution for those Mahakumbh. But even though but looking after those solutions, these type of crowd management problem has been not solved yet. Energy management, urban mobility, water, and these are the some challenges. And getting the smart city mission into the India, Indian government is giving too many funding to the societies and the academia and the industry. So, application development, data management, architecture, orchestration of workflows, cybersecurity, and integration, determining and business requirements. These are the top inhibitors to the adoption of the IoT. And for those IoT in the smart cities, International Telecom Union has under the WTSA 16 group, that is study group is 20, and they have working on the machine to machine partnership working space, where the embedded service layer is connected to the network to deliver the IoT service platform for IoT device application and IoT service server application. So this is the connected machine. First is the IoT device, and the cloud infrastructure is the employing over the IoT infrastructure. So here is the working space, and when we are talking about the one architecture approach. So here device is connected to the local network, and gateway is going for the communication, and there is a application which is going over to the horizontal side, and we have so many devices connected, so many communication network connected, and common service layers are there, and application layers is given on to the horizontal. So here we can see the gaps with reference to three AIoTI HLA layers that under the groups giving for specific unified model tools for development and the management. So from vertical to horizontal
Hello,
platform.
ma'am.
Yes. Hello.
Uh, ma'am, just a minute, ma'am. Hello, ma'am.
Yes, 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 please. Are you there?
Hello, ma'am.
Yes, please, yes. Give me 2 to 3 minutes. I'll going to wind up.
Actually, ma'am, there's some issue with the voice. Just give us a minute, ma'am.
Yeah, sure.
Hello, ma'am.
Yes, sir. Yes, sir.
Could you, ma'am, please check your side, ma'am? I guess there's some issue from your side, ma'am.
No, actually, I think my network is proper. Are you able to listen me now? Hello. Hello.
Hello.
Are you
Are you
are you
are
able
you able
to
to
listen me?
listen me?
Am I
I'm
audible?
audible.
फिर से लॉगिन करने बोलो भाई फिर से फ्रीज हो गया हेलो मैम
Yes, yes.
Yes, yes, please.
लाइव स्ट्रीम आवाज आ रही है पर यहाँ आवाज नहीं आ रही स्पीकर स्पीकर चेक कर स्पीकर को चेक कर यहाँ से हट के दूसरी जगह तुम
हेलो मैम
Hello. Am I audible?
इसको अचानक से हुआ
हेलो मैम
आवाज नहीं आ रही आवाज कैसे आपका नहीं आ रही आवाज कैसे इस वाले में इस वाले में नहीं अरे उस दिक्कत क्या होगी एक साथ ऐसी तो बहुत लैग आएगा इस वाले
infrastructure. So we have the three C's and three I's. The three C's are for the connect, compute, and the control. Okay, so connect, compute, and the communicate under the system, cyber, and the physical. So here we can see smart cities is an incremental and participatory journey, and that is given by the 5 year. So that is efficient and open, truly smart. So in the efficient and open, whatever the device one is communicating to the connectivity and intelligence, we like here I have given the waste management, gardens and the parks, and the public lighting. So vertical solutions bringing efficiency in silos and historic data as open data information is still in vertical silos, no global picture. Truly smart horizontal platform integrating right time context into from different vertical services, predictive and perspective models. So we have the smart devices, smart connectivity, and the smart platform, and unleashing right time open data. So right time context into published to third parties. Like what? I'm just going to build a traffic monitoring software. Okay, so solution for the traffic monitoring and all those things, but my data is on not the real time, and whatever the solution I'm developing, if it is the like just trying to predict the accuracy and all those things without any real time data, that doesn't having any sense. So exchange of context information into the system from other domains, support to data economy. So my data is the my citizenship and the populated states. So it has the city as a platform, including also third-party data enabling innovative business models, open and commercial data enabling multi-site markets. So this is the reference architecture model for the smart city given by the Fiverr, because I already told you so many companies are giving the ICT solution for the nations developed and the developing nation. So we have the existing vertical solution, whatever the public transport, car sharing and bicycle sharing, traffic control, smart parking, and the air quality. After that, they have deployed the IDS as a framework that integrating the NGSI agent and NGSI IoT agent, and they are implementing the RN context broker, that is a city context information management layer. So like bus solution, location, route, next stop, time, next stop, bicycle parking, parking space, shared car, street, and after that they are like different UI solution, and after that smart city governing services, where we have the CEP rules and actions, that is the context management and big data algorithms, KPIs monitoring, advanced data maps, operation dashboard, and multimodal and intermodal services marketplace. So this is the context information management layer, where that is specify target of industry specification group, and developing the vertical solutions. So another solution is from Synchronicity, that given for the 8 European cities and 3 outside the Europe. So it is also a different kind of solution which is given by the Synchronicity. So I'll just tell you the one example, and will wind up after because of time issue. So IoT for wearable devices and related services, there are so many exoskeletons which is going to deploy to ease of uses of weights and other things. So here we have seen the mind controlled arm processes. This is a cognitive solution for the limb amputation or impairment. So these processes aim to restore natural and intuitive control over prosthetic limbs by directly connecting them to the user's brain signal. So here, whatever, if I just want to move my hands, I don't want to move my hands, but my brain is instructing. So this kind of mind control processes are controlled by the cognitive science, and these hands are moving as well as my thinking process. So this is developed, and BCIs is used for the brain-computer interface to giving the ability to the impaired people. So these are the healthcare cyber physical system, where we are having the embedded skin patches to have the neuro solution and all. Another solution is like we have this smart streets. So they have the polluting points location, noise maps, weather condition, liquid presence over payments and icy road, and crack monitoring, vehicle presence, vehicle and registration, analysis. So these are the flood point monitoring. So these sensors are enabled into the like roads, and people, whenever there are some collision or flooding situation, so sensor will alarm to the management people, and people can track where these flooding points are giving are there. And another one, last solution is the Dubai UAE RTS laser technology can detect 1 mm cracks in roads. So they are using AI technology and enable the LIDAR solution. So on the track, they have just identifying the 1 mm pit holes, and those potholes are filled by transform AI technology. So these are the virtual mapping and the camera solution, AI integrated pit hole solution for filling the pit holes over the roads. So there are so many solutions which are developed by the smart energy urban spaces by the Indian government too. So so here, if there is any question related to this, because of time issue, I'm just winding up right now, and I just want to convey that for the urbanization, we have to look into the solution, because of in the metro city we are lacking with the water and road and transport problems. So we have to build such kind of solution as an academician, as the technocrat. Thank you so much.
Thank you, ma'am, for joining us today and thank you, ma'am, for joining us today and sharing your great knowledge and experience with us. Now, I'm pleased to any queries? Now, thank you so much. Thank you so much, ma'am, for your insightful session.
Thank you, ma'am.
So, since we have the preparations for high tea ready, so it's a request for all the participants and the session chairs kindly join for high tea. After high tea, we'll continue the session, the technical session. Thank you. Sir, नहीं इधर ही है जी. Please proceed towards high tea. Only 5 minutes.
इसको एंड वापस से शुरू कर पूरा पूरा वापस स्टार्ट कर
microstrip antenna with IED 3D. Third paper was the wideband omnidirectional antenna array with low gain, in which we find that the author introduced the 3D dipole with vertical arms, and their limitation was that their antenna works for 2G, 3G, and LTE systems. Here are the several literature reviews based on finding and limitations. We have used CST Microwave Studio Suite Learning Edition and CST Microwave Studio 2023. Here are the methodology and implementation of the given paper. We have selected two antenna types. First one is dipole antenna, which is known for their omnidirectional pattern and simplicity. And second one is the circular monopole MIMO antenna, which is lightweight, compact, and suitable for directional applications. Here are the design of dipole antenna using CST Studio State. These are the design parameters of the dipole antenna, where resonant frequency is 2.4 GHz, wavelength is 125 mm, calculated from the formulas, and length of the dipole antenna is calculated, that is 62.5 mm, and radius of the dipole is 0.125 mm. Here is the second geometry of the antenna, that is circular monopole MIMO antenna, in which we have used the FR4 substrate, and we have two circular patches. And we have used waveguide port to simulate this antenna. Here are the back view of the partial ground we have used to design this antenna. These are the design parameters of circular monopole MIMO antenna, where the higher cutoff frequency is 3.1 GHz and lower cutoff frequency is 10.6 GHz. We use the radius of circular patch is 4 mm, and width of the circular patch is 0.035 mm. Length, width, and height of the substrate are given here. Here are the result based on the for the simulated S7 half wave dipole antenna, which is resonating at 2.4 GHz approximately, and the return loss is minus 31.827 dB. This is a simulated VSWR of the half wave dipole antenna, which is less than